So hopefully by now I have convinced you that when the sample size is greater than or equal to 30, then sample means x bar will be normally distributed. Regardless of the distribution of the underlying variable. Okay? But we haven't talked about the two other elements of the sampling distribution of the mean, right? So let's look at a quick example. Suppose I have a population with 4 observations of the variable x, and the 4 observations are 1, 4, 6, and 2. Okay? So we have a population size of 4, population mean of 3.25, and a population standard deviation of 1.92. Okay? Suppose I'm interested in samples of size 2. Okay? Now first off, let's go ahead and list all the possible samples of size 2 taken from this population. Okay? So I'm gonna have 1, 4 as my first sample, 1, 6 as my second sample, 1, 2 as my third sample. Okay? Then I'm gonna have 4, 1, 4, 6, 4, 2, and then 6, 1, 6, 4, 6, 2, and then 2, 1, 2, 4, and 2, 6. Okay? In other words, I have 12 possible sample. Okay? So for each of these samples, I want to calculate the sample mean. So I have x1 bar of 2.5, x2 bar of 3.5, x3 bar of 1.5, and so on and so forth. Okay? So I have 12 possible sample means. Okay. Now the mean of these sample means, so mu of x bar is equal to x1 bar plus x2 bar plus all the way to x12 bar divided by 12. If you do the calculation, that gives you 3.25. Okay. And then the standard deviation of these sample means. Remember that this is also referred to as the standard error of the mean. It's going to be 1.11. Okay. Now what does the theory say? Remember, the theory tells us that the expected value of all the sample means, which is equal to mu of x bar, should be equal to the mean of the underlying variable. In this case, they are both equal to 3.25. Now when it comes to the standard error, in this case it's a little complicated to do, so I'm not going to do it, but always remember that the standard error of the mean is equal to the standard deviation of the underlying variable divided by the square root of the sample size. Okay, so these are the two formulas that you want to remember.